Start. Okay. Then next topic is about effect of the frequency of incident light on photoelectric current. Uh, for a fixed intensity of incident light, the photoelectric current does not depend on the frequency of the incident light. Because the photoelectric current simply depends upon the number of photoelectrons emitted in terms on the number of photons incident and not on the energy of photons. ठीक है, ये क्लियर है? तो फोटोइलेक्ट्रिक करंट जो होता है वो फ्रीक्वेंसी पे डिपेंड नहीं करता है. ठीक है, फोटोइलेक्ट्रिक करंट ओनली डिपेंड्स अपॉन द इंटेंसिटी ऑफ लाइट. ओके,
Yes, sir.
नेक्स्ट. Effect of the frequency of incident light on stopping potential. X-axis is the stopping potential, Y-axis is the current, and this is the graph for different frequency of light. There is frequency mu1, mu2 and mu3. Okay, you can see when frequency of light is mu1, then the stopping potential is Vs1, and when frequency of light is mu2, then the stopping potential is Vs2. It means that if we change the frequency of light, then the stopping potential will also change. According to the photoelectric equation, I will explain photoelectric equation 1 minute. Like from conservation of energy, from conservation of energy, light energy h nu is equal to the work function. Work function is h nu naught and plus kinetic energy
of the
eV naught. Okay, eV naught is the kinetic energy of photoelectrons. And you know that, you see that this frequency is depend upon the stopping potential. If we change the stopping potential, then frequency of light is also changed. And work function is constant. For a given material, work function is constant. It means frequency only depends upon stopping potential. If we change the stopping potential, if we change the frequency, then the value of the stopping potential is also changed. Okay?
Sir, is there any relationship between work function and threshold energy?
Threshold energy. Okay, threshold energy and work function. Work function means that this is the minimum amount of energy required to emit the photoelectrons from the metal plates. किसी भी मेटल प्लेट से इलेक्ट्रॉन को रिमूव करने के लिए, फोटो इलेक्ट्रॉन्स को रिमूव करने के लिए जितनी एनर्जी की रिक्वायरमेंट होती है उसी को हम क्या बोलते हैं, वर्क फंक्शन. अगर हमें ज़्यादा एनर्जी देना पड़ रहा है तो वर्क फंक्शन ज़्यादा होगा. ठीक है, इलेक्ट्रॉन को रिमूव करने के लिए. तो अब देखो, however the saturation current is same for different frequency of the incident light. सैचुरेशन करंट जो होगा वो हमेशा क्या होगा, कांस्टेंट होगा. क्यों? क्योंकि हमको पता है कि करंट केवल इंटेंसिटी पर डिपेंड करता है, ये फ्रीक्वेंसी ऑफ लाइट पर डिपेंड नहीं करता है. तो यही रीजन है कि करंट कांस्टेंट है. करंट क्यों कांस्टेंट है? क्योंकि लाइट की इंटेंसिटी कांस्टेंट है. ठीक है, करंट नॉट डिपेंड्स अपॉन फ्रीक्वेंसी. नेक्स्ट. Higher the frequency, higher the stopping potential. Already I have explained. Stopping potential depends upon the frequency. Next, threshold frequency. You can see this is the graph. On the x-axis, this is frequency, and on the y-axis, this is the stopping potential. And this is origin O, and we are plotting the graph between the stopping potential and the frequency. The graph between stopping potential and the frequency does not passes through the origin. It shows that there is a minimum value of frequency called threshold frequency, below which photoelectric emission is not possible. However, high the intensity of incident light, it depends on the nature of the metal emitting photoelectrons. Okay, you know that, again I am explaining. You know that from photoelectric equation, light energy किसके इक्वल होता है? What is the light energy? Light energy means energy of photons. This is equal to the work function. Work function
plus the kinetic
plus
energy of the photon.
Yes, kinetic energy of photoelectrons. kinetic energy of photoelectrons. Okay. Now we are putting the formula. You know that light energy is h nu. This is h nu, and work function is h nu naught. What is nu naught? Nu naught means threshold frequency, and plus kinetic energy of electron. This is eV. Okay. We want to plot the graph between stopping potential and the frequency. Then h nu minus h nu naught is equal to eV naught. Therefore, V naught, what is V naught? V naught is equal to h upon E nu minus h nu naught upon E. Where h is Planck constant, nu is frequency, and nu naught is called
threshold frequency,
and E means magnitude of charge.
Electron.
Okay, and we are comparing this with the equation of straight line. You know that the stopping potential is on the y-axis, so we consider y. Frequency is on the x-axis, so we consider x. And we are comparing the equation of line y is equal to mx plus c. Y is equal to mx plus c. Then the slope of x, the coefficient of x is slope. Then the coefficient of frequency is slope. Then according to this equation, slope of line is equal to h upon
Planck's
E.
constant upon E.
Yes, line constant upon E, and the cutoff intercept on y-axis minus h nu naught upon E. Minus h nu naught upon C. C is called cutoff intercept on the y-axis. You are seeing on the graph. You can see. You can see on the graph. यहाँ पे आप देखो, यहाँ पे क्या हो रहा है? हाँ, तो बताओ जरा, ये बताओ यहाँ पे ये कट ऑफ इंटरसेप्ट कितना आया था? हाउ मच?
h nu naught upon E.
और इस लाइन का स्लोप कितना था?
h by E.
Okay.
Yes.
And cut off intercept on x-axis is nu naught. Cut off intercept on the x-axis is nu naught. What is nu naught?
Threshold frequency.
Okay. Now, the graph between stopping potential and frequency does not pass through the origin. You can see a graph is not passing through the origin. Below which it shows that there is a minimum value of frequency called threshold frequency, below which photoelectric emission is not possible. However, high the intensity of incident light may be, it depends upon the nature of the metal emitting photoelectrons. Okay?
Yes, sir.
Again, we explain the law of photoelectric emission on the basis of this graph. Then from the first graph, we explain the first law. From the second graph, we explain the second law, and from the third graph, we explain the third law. According to the first graph, for a given substance, there is a minimum value of frequency of incident light called threshold frequency, below which no photoelectric emission is possible. However, the intensity of incident light may be. लाइट फोटो इलेक्ट्रॉन्स तभी इमिट होता है जब लाइट की फ्रीक्वेंसी मेटल प्लेट के थ्रेशोल्ड फ्रीक्वेंसी से ज़्यादा होना चाहिए. ठीक है, ये पहला हो गया. दूसरा, the number of photo electrons emitted per second means photoelectric current is directly proportional to the intensity of incident light, provided the frequency is above the threshold frequency. ठीक है, तो मतलब जो फोटो इलेक्ट्रिक करंट जो होता है किस पे डिपेंड करता है? इंटेंसिटी ऑफ लाइट पे. ठीक है. Third, the maximum kinetic energy of the photoelectron is directly proportional to the frequency, provided the frequency is above the threshold frequency. इलेक्ट्रॉन, फोटोइलेक्ट्रॉन्स की काइनेटिक एनर्जी किस पे डिपेंड करती है?
फ्रीक्वेंसी पे.
फ्रीक्वेंसी अगर ज़्यादा है, लाइट की फ्रीक्वेंसी ज़्यादा है, तो ये फोटोइलेक्ट्रॉन्स की काइनेटिक एनर्जी क्या होगी? ज़्यादा होगी. ठीक है. Fourth point, the maximum kinetic energy of the photoelectron is independent of the intensity of incident light. काइनेटिक एनर्जी जो होता है वो इंटेंसिटी ऑफ लाइट पे डिपेंड नहीं करता है. फोटो इलेक्ट्रॉन्स की काइनेटिक एनर्जी इंटेंसिटी पे डिपेंड नहीं करता है. लास्ट, द प्रोसेस ऑफ फोटो इलेक्ट्रिक इमिशन इज इंस्टेंटेनियस. एज सून एज द फोटोन ऑफ सुटेबल फ्रीक्वेंसी फॉल्स ऑन द सब्सटेंस, इट इमिट्स फोटो इलेक्ट्रॉन. तो ये कैसा प्रोसेस होता है? स्पॉन्टेनियस प्रोसेस. मतलब अगर एक फोटोन इंसिडेंट हो रहा है तो तुरंत आपका फोटो इलेक्ट्रॉन्स क्या होगा? इमिट होगा. ठीक है, इसलिए इसको स्पॉन्टेनियस बोला जाता है. नेक्स्ट, The photoelectric emission is 1:1 for every photon of suitable frequency, 1 electron is emitted. अगर एक फोटोन अगर इंसिडेंट हो रहा है तो एक फोटो इलेक्ट्रॉन्स क्या होगा, इमिट होगा. Next, Einstein photoelectric equation. I have already explained this. You can see when a photon of energy h nu falls on a metal surface, the energy of the photon is absorbed by the electron and used in the two ways.
First is the energy of the threshold or the work function,
Yes.
and another is the kinetic energy.
Correct. First is a part of energy is used to overcome the surface barrier and come out of the metal surface. This part of the energy is called work function. Or I will explain in simple word. Work function is the minimum amount of energy required to emit the photoelectron from the metal surface. किसी भी मेटल सरफेस से फोटो इलेक्ट्रॉन्स को इमिट करने के लिए जितनी मिनिमम एनर्जी की रिक्वायरमेंट होती है तो वो उस मेटल प्लेट का क्या कहलाता है,
Work function.
Second point, the remaining part of the energy is used in given a velocity d to the emitted photoelectron. This is equal to the maximum kinetic energy of the photoelectrons half m v square, where m is the mass of photoelectrons. तो अगर मान लो लाइट अगर इंसिडेंट हो रहा है किस पे, मेटल प्लेट पे, तो उसमें कुछ एनर्जी जो है मेटल प्लेट एब्जॉर्ब कर रहा है और बाकी का जो एनर्जी जो है वो काइनेटिक एनर्जी में कन्वर्ट हो रहा है. एंड ड्यू टू दिस काइनेटिक एनर्जी photoelectrons are emitted. Okay. Next. You can see this is the photon. Photon is incident on the metal plate and photoelectrons are emitted. And the threshold frequency, this is the work function. Work function is h nu naught. Work function phi is equal to h nu naught, where h is the Planck constant and nu naught is called threshold frequency. Okay, and this is the photoelectrons. When one photon is incident, then one photoelectrons are emitted from the metal surface. You can see electrons are emitted from the surface and its kinetic energy is half mv square, and this is the maximum kinetic energy. According to the law of conservation of energy, h nu is equal to phi plus half mv square, h nu naught plus half mv square. Half mv square is equal to h nu minus nu naught. H is the Planck constant, nu is the frequency, and nu naught is the
Threshold frequency.
Okay. Next, verification of the law of photoelectric emission based on Einstein photoelectric equation. तो आइंस्टीन का जो फोटोइलेक्ट्रिक इक्वेशन है इसकी बेसिस पे हमें फोटोइलेक्ट्रिक इमिशन का वेरिफिकेशन करना है. हाउ? half mv square is equal to h nu minus nu naught. If nu is less than nu naught, then half mv square is negative, which is not possible. अगर लाइट की फ्रीक्वेंसी मेटल प्लेट की थ्रेशोल्ड फ्रीक्वेंसी से कम है तो हाफ mv स्क्वायर क्या होगा, नेगेटिव, एंड यू नो दैट दिस इज नॉट पॉसिबल. Therefore, for photoelectric emission to take place, nu is greater than nu naught. लाइट की फ्रीक्वेंसी मेटल प्लेट के थ्रेशोल्ड फ्रीक्वेंसी से ज़्यादा होना चाहिए. Since one photon emits one electron, so the number of photoelectrons emitted per second is directly proportional to the intensity of incident light. ये तो हम लोग ऑलरेडी डिस्कस कर चुके हैं कि फोटोइलेक्ट्रिक करंट या नंबर ऑफ फोटोइलेक्ट्रॉन्स इंटेंसिटी पे डिपेंड करता है. It is clear that half mv square.
सर जो न्यू है अगर वो न्यू नॉट से अगर कम है तो मतलब कि फिर तो वो थ्रेशोल्ड जो वर्क फंक्शन है वो रिलीज ही नहीं कर पा रहा है.
हाँ,
तो वो
काइनेटिक एनर्जी नेगेटिव आ रहा है.
हाँ, तो फिर वो इलेक्ट्रॉन सिर्फ वाइब्रेट करके वहीं पे रुक जाएगी ना.
यस, इमिट ही नहीं होगा. अगर आप लाइट को अगर आप इंसिडेंट करोगे तो इलेक्ट्रॉन्स इमिट ही नहीं होगा,
बस थोड़ा सा वाइब्रेशन होगा क्योंकि एनर्जी पास करवा.
बस केवल वाइब्रेशन ही होगा. It is clear that half mv square is directly proportional to frequency, as h and nu naught are constant. h और nu naught क्या होता है, constant. This so that kinetic energy of the photoelectron is directly proportional to the frequency of incident light. तो काइनेटिक एनर्जी किस पे डिपेंड करता है, फ्रीक्वेंसी ऑफ रेडिएशन पे. ठीक है. Photoelectric emission is due to the collision between a photon and an electron. As such, there cannot be any significant time lag between the incident of photon and emission of photoelectron. The process is instantaneous. It is found that delay is only 10 to the power minus 8 second in order of nanosecond. स्पॉन्टेनियस प्रोसेस होता है, मतलब आपने जैसे ही फोटोन को इंसिडेंट किया, फोटो इलेक्ट्रॉन्स तुरंत क्या हो रहा है, इमिट हो रहा है. एप्लीकेशन ऑफ फोटोइलेक्ट्रिक इफेक्ट. फोटोइलेक्ट्रिक इफेक्ट का यूज क्या है? ठीक है, तो देखिए ऑटोमेटिक फायर अलार्म्स, ऑटोमेटिक बर्गलर अलार्म्स, स्कैनर इन टेलीविजन ट्रांसमिशन, reproduction of sound in cinema film, in paper industry to measure the thickness of paper, to locate flaws or holes in the finished goods, in astronomy, determine the opacity of solid and liquid, automatic switching of street light, to control the temperature of furnace, photometry, beauty meter to measure the fair complexion of skin, light meter used in cinema industry to check the light, photoelectric sorting. A lot of using of the photoelectric effect in our modern technology, especially automatic switching of street light is we always we see in our locality, in our society. Next, and also meteorology. Next part is about dual nature of radiation and matter. Dual nature of radiation and matter. This is complete.